Welcome everyone to today's explainer. I'm absolutely thrilled you're here because we're about to take a highly focused, really intimate dive into a very specific piece of a developer's journey. Now, we aren't looking at high-level textbook theory today or some broad overview of software architecture. Instead, we're looking directly into a developer's raw journal entry to extract a real-world micro-case study on software testing. Broad overviews are great for the theory, but looking at a single developer's daily commit, that helps us understand the microscopic realities of software engineering. It's literally where the theory meets the keyboard. Let's get right into it. Okay, let's dive into this. Part 199. Wow, that number alone highlights the staggering dedication and persistence required to master complex systems like Haskell programming. This explainer is actually based on a journal entry by a developer named Eng. And honestly, it takes immense discipline to document a software journey step by step, capturing all those granular details of testing and refactoring, all the way to entry 199. It's a real testament to the daily grind of building robust code. Looking at the metadata, we see it was published on July 29, 2026. Yep, exactly today's date. Eng addresses this directly as a dispatch to the, quote, Dear Interweb. It's a brief, highly specific little update. But you know what? It perfectly encapsulates the continuous, step-by-step, iterative journey of software testing. It really shows us that real, sustainable progress happens in these small, well-documented increments. Section 1. Refactoring with Dependency Injection. This brings us right to the core mechanical change that triggered this specific journal update, preparing us to look at the exact mechanics of what was altered. So the crucial point is right here in Eng's own words. They write, refactored the openEbook function via dependency injection by adding a runner argument. This specific milestone is actually a direct follow-up to part 197 of Eng's journey, which focused heavily on this openEbook function. To achieve true dependency injection, the vital change was adding a new runner argument right into the function's signature. So let's really unpack that. Instead of hard-coding the execution environment directly inside the function itself, Eng is now passing that runner in from the outside. This is a game changer. It completely detaches the function from a rigid context, making it way more flexible and modular. But by doing this, it forces a massive change in how the function behaves out in the wild, and crucially, how we have to verify it in a testing environment. Section 2. Analyzing the test diffs. So, how do we actually know this refactor changed the testing landscape? Well, we look at the crucial evidence. We look at the exact diffs. Now, what's really interesting about this slide is how the testing requirements fundamentally shifted. Notice the old import requirement on the left. It used to only pull in isWrite from the data.either library. But check out the new import on the right. The code now explicitly requires both isLeft and isWrite. In Haskell, the either data type is just incredibly powerful for robust error handling. isWrite typically represents the successful state, the data we actually want. isLeft, on the flip side, represents the failure state, usually holding an error message or an exception trace. Because of that dependency injection we just talked about, testing only the success state just doesn't cut it anymore. By injecting a runner from the outside, the code now explicitly has to account for and aggressively test those failure states. It proves the testing requirements have expanded to catch complex errors that an external runner might introduce. Let's move to and see how this builds. To accommodate these dependency injection test cases, Eng had to pull in specific new dependencies, control.exception for throw.io, the openEbook function itself from x2ebook.converter, and finally a brand new describe block, specifically targeting openEbook. Every single line added here is a direct reaction to injecting that runner argument. Creating a brand new describe block means carving out a completely isolated testing space purely for this refactored logic. The openEbook function has grown complex enough that it now demands its own rigorous, specialized suite of validations rather than just being lumped in with generic tests. Okay, I want to pause for a second here. Look specifically at throw.io. By pulling this from control.exception, Eng is bringing in the heavy machinery of the Haskell ecosystem. Now that the runner argument is in place, simulating complex edge cases and handling input/output exceptions, it becomes absolutely crucial. Why? Well, external dependencies bring massive unpredictability. You are no longer in total, pristine control of what the function receives. You can't just test the happy path anymore and assume operations will succeed as planned. You have to actively simulate the environment breaking. You have to throw intentional I/O exceptions to ensure everything handles catastrophic failure gracefully without crashing the whole system. So, looking at all these additions, the explicit exception handling, testing the left and right states, the new imports, is this the perfect solution? It's a vital question to ask. And it really challenges this whole idea of finished software. When we refactor, do we ever actually reach a state of perfection? Let's pivot and look at how the developer themselves views this milestone. Section 3. The future of the code. This prepares us for Ang's philosophical conclusion on continuous iteration, because, spoiler alert, software is never truly done. And this brilliantly illustrates the true nature of programming. Just look at this sign-off. Of course, there are ways to improve this further or code it differently, but nevertheless, that would be another discussion for another time. Till the next post, yours truly, Ang. I love the slight typo there, of course, with 2 Fs. It perfectly humanizes the entire commit. Ang acknowledges immediately that this isn't a final, perfect state. Think about how this casual, almost breezy sign-off sharply contrasts with the highly technical code diffs we were just analyzing. It turns a mundane code commit into a compelling narrative of continuous, humble improvement. Another discussion for another time. That's pretty much the ultimate mantra of any working software engineer. It's an acknowledgement that this is just one step in a never-ending journey of breaking things and refining code. So as we wrap up this micro case study, the ultimate takeaway is simple. The code is never truly finished. Whether you're on part 1, part 199, or part 1,000 of your own journey, there's always another edge case to test, always another dependency to inject. So looking at your own work today, what will you refactor next? Thank you so much for joining me for this explainer, and I really hope you leave today feeling inspired to dive right back into your own code.